Okay. Hi everyone. We will be discussing how to extend PMM with custom collectors, and not only custom collectors. We will only briefly mention another way of extending PMM, that is with the external exporters. So I'm Agustin. I work at the support team in Percona, and I work very close with the PMM dev team and the customer issues that we have with PMM, so we can help them resolve faster and in a better way. So very quickly, we are going to discuss about the architecture of PMM, so we can understand how the internals working, and then the interface to know how to get the data that we need from. Before we try to do anything custom, it's always good to make sure it's not done already. So then we will discuss the custom query collector, the Textfile Collector, and the external exporters. So I'm going to briefly go over this because I'm sure you already know if you're here, but PMM is actually a suite of tools that are built together for the purpose of monitoring and managing database servers, right? So the most important ones, or at least the most visual ones from a client perspective, are Grafana and Victoria Metrics, which previously we used Prometheus, and ClickHouse. So Grafana is the one in charge of displaying the metrics and the information regarding queries. Victoria Metrics is in charge of storing the metrics, and ClickHouse is in charge of storing the query-related data. Then we have PostgreSQL for internal configuration stuff and other tools like Nginx. So what do we get from PMM out of the box? We get support for Postgres, Mongo, and MySQL. For MySQL and Mongo, we also have of course, support for our own distributions of them and other tools like ProxySQL. We can have our own on-premise servers and also cloud deployments monitor, right? So in terms of architecture, PMM follows the server-client architecture. I'm not going to say much about it because you surely know what it works, but we have the PMM server component on this side, which is actually going to be connected to all of the clients, which are going to send metrics in either pull, if they wish for PMM server to actively poll the clients for data, or in push mode, which means that the client will be sending the metrics to the PMM server, like actively sending it. Right? This is why one of the main reasons we changed from Prometheus to Victoria Metrics, because with Prometheus you only get the pull, the pull mode, right? So you need to have the ports open, etc., right? This not only makes it easier to set up PMM, the PMM client, but in the future it will also give us of buffering local to the PMM client, buffering metrics, so we can withstand some network glitches and at low network errors. So why is monitoring needed? They know this, so I'm not going to discuss much more about it. And then regarding the PMM interface, it's important to be able to know how to read the information that PMM is giving us. So there are three levels of depth here. The metrics are the most atomic ones, the most basic ones, and then there are graphs that are basically groups of metrics with right. So they do have they are aligned into what the graph wants to say, or the story we want to tell, and the dashboards are groups of graphs that, for instance, the MySQL summary or the OS summary will get us the big picture over either the OS side or the MySQL side.
What's the frequency to collect the metrics from the client?
Right. There are three levels here. there is the high level, the medium, and the low. So this is called the resolution,
so
right?
What's the default when you insert the PMM client on
Right.
the server?
By default, you have the high one is 5 seconds. It can go as low as 1. In PMM1, it used to be 1, but we realized that it may be too much for all cases. So now by default, it's 5 seconds, which is low enough. But if you want to have per second metrics, which you can with PMM, you need to make sure you lower it from the PMM settings. I will show you how to do it.
Got it. Yeah. Which helped me to answer a question I had with Marcos yesterday for the MySQL. When they are talking about the transaction load, the unit RPM per second, and I see why we have any decimal display. If you have like, I'm assuming that's an integer. So he said because that's a kind of derivation for the length of the 5 seconds. So it's a kind of
yeah, and actually the load is a bit tricky, and
because the other matrix I mentioned to you yesterday,
Yeah.
Wavefront, the default is calculate the matrix from your target server every 1 second.
right,
So their default is getting the data point every 1 second.
Right.
So this one is the default is getting matrix, actually average 5 seconds.
yeah.
I see.
Yeah, and you can, this is where you would check, right? So this is a PMM settings page.
Yeah.
By default, it will take you to a matrix resolution, and the standard is 5, 10, and 60. You can use less, more, or custom. So you can leave this at 10 and 60, and then lower at 1, or however you want. But yeah, it's. Okay, so what I said before extending a tool, it's also needed to know what the tool can give us, right? So we need to be able to all the dashboards through all the graphs and make sure that the information we want is not already there. So this is the home dashboard. This is the first thing we will get when we are greeting PMM, which has all of the environment will be listed as right. So this gives us a bird's view of our fleet, right? Then we have or you can go to this menu and start traveling all of the different menus here, right? And then we have the time range selector at the top right. We go to the MySQL instance summary. We have also a menu here to select which node in particular we want to check. The interval, typically you don't want to touch it, and to see if we are getting annotations, to see if we want to see them. At some point, maybe you can have so much annotations that they get in the way, so this is very helpful. And then over here, we can also dive into more MySQL related dashboards, or even go to the query analytics page. So how can we extend PMM? There are 3 ways. I'm going to focus on the first 2 because really, to be honest, external exporters, there is not much to say. You just have to search for one, may work for you, and the installation steps are really easy. So the most interesting ones for me to talk about are the custom queries and the Textfile Collector, right? All of them, and we were discussing before, them offer the same levels of resolution. They will all gather metrics in the high, medium, and low resolution times, right? Of course, it's on us to decide what level we want, right? And for instance, we are going to discuss this soon, but if we have a in 10 seconds, then we are not going to be able to have it in the high resolution because that will overlap with each execution will overlap with the previous one, right? So it's very important to make sure we know the execution times that we are going to be having for each and set in the appropriate level. And then another important thing here is that PMM will do all the hard work for us adding the appropriate labels that we can then use to filter the metrics in PMM, in Grafana itself, right? So we only need to get we don't need to worry about mapping from which node this is coming and all the other internal metadata PMM client handles for the already metrics, right? So the custom queries are defined in YAML files. Textfile collectors will actually, as the name implies, will just read the file and get the metrics from it in the expected Prometheus definitions, and then the external exporters, just like if you can think of them as the exporters that we currently have, like the Node exporter and the MySQL exporters, just that we didn't add them beforehand, right? So you will need to add to run the exporter, for example, the Cassandra exporter. Cassandra exporter, we the metrics, push them to a port, and the only thing you will need to do is tell PMM client this is where the metrics are going to be, right? So let's go ahead and talk a bit about the custom query collector. So as we mentioned before, the queries are defined in the YAML files, right? And the nice thing here, and this is what one of the benefits of the query collector, is that the PMM client connection to the database is already known by PMM. So you will not worry about connection to, because that is already managed by PMM client, right? So the only thing you need to worry is to have a query that makes sense for what you want to get from the database, right? So if you have the query that gets the data set that you want, that is what you need, and then you need to know how to map the columns in the YAML file, but we are going to talk about that now. The only downside of this is that MongoDB is not supported for now. We will get only support for MySQL and Postgres. There is a there that is a clickable PDF. So where do we create the YAML files? These are going to be in user local Percona, PMM2, collectors, and custom queries, right? And then from custom queries, we have MySQL and Postgres, and then the resolutions we mentioned before, right? So this is up to you to decide which resolution you are going to use, and it's an important decision. So you need to test this. Or I remember we were at the PGConf last year with Charlie, and we used for PostgreSQL, we used heavy queries on the high resolution, which were really, really heavy queries, and it killed the server. So we need to really be careful of it. I would say test it before. Make sure the queries, even with high load, they are not too taxing on the DB server, because PMM client will not make sure, will not have any QA, let's say.
So for that reason, we don't have to supply low, medium, and high, right? We could just do like low and medium or something?
Yes, yeah, you can even go.
Is there anything wrong with that?
No. That's a perfect, I mean.
But you have to put it in the right folder.
Yes, yeah. Yeah, but it's a solution to a problem. Yeah, yeah.
And it is possible to do custom resolution for specific metric.
What do you mean by customize?
Maybe 1 hour to collect the data.
Oh, no. It's not like run. You say, like you could say, okay, run at noon every day. Yeah, no.
So it's a time series.
Yeah.
It's time series. What you can do is you can just limit the timeline, the range when you look at the data. So for example, 1 hour for the data, but you cannot control when to start and stop collecting metrics.
No. For that, I would use the Textfile Collector,
Okay.
because with that, you do have the control on when the file is generated. This will run if you have the file here. This will run every 5 seconds, and it will try to connect to the MySQL server that is being.
The only way I could think of to do that would be to check the local time in the query and say, if it's plus or minus 5 minutes of 12 noon, run the job.
Right.
Otherwise, just return immediately.
Right. Yeah.
No data.
Yeah. The query will still run, but it will. Yeah, you will have that fail safe. Yeah.
You set it down.
Right.
You mentioned something about the text file and it being generated in the Textfile Collector. How would it respond if you had the text file only there like at noon?
That's fine because think of it as metrics not changing. So if it will be, let's say your query returns always 0. In that sense, it's the same.
So in that case, you would have like data point, no data,
0, 0, 0. Yeah, no data, no, 0. Or yeah, maybe if you don't have any data, you would say no data. But if it's static, if you write the file once, that is what is going to be read every time.
Yeah, but if you write it once and then maybe delete it.
Oh, if you delete it, that's another, yeah.
But then you've got timing issues, like you might not have deleted it fast enough, and it may have ran twice, or maybe you didn't, or deleted it too soon.
Yes, yeah, and that is also something we need to, we will discuss soon, but we need to be careful of overstepping between, like, if you are writing to the file and then the exporter is trying to read from it, it could be, there could be some dirty data or partial reads. So what I did in cases like that is I write to a temporary file and then you swap it. And that is like atomic, so, yeah. How does one thing I didn't explain is these are coming by default. So queries MySQL D, which probably will need to change the name because we should name them like example queries Postgres like we have here. So the queries MySQL D.yaml and the example queries Postgres will have like a file which is all commented out with the skeleton of how we expect the files to be. Right? So how we expect the files to be, something like this. So the first thing here would be like the namespace, which is basically the string that will be prepended to all the metric names. Right? So all of our metrics for this query collector will start with MySQL performance schema, which may not be the best naming for an example, but you understand. So imagine like MySQL namespace 1 here, right? And then we will have, these are the metrics, which are the columns that our select returns. And each metric will be MySQL performance schema column 1, MySQL performance schema column 2, etc. Right? So these will be useful when we need to create our own graph or to check the if the metrics are being correctly exported from the PMM client. Right? So the query can be whatever you want it to be. So it just, as we were discussing before, it just needs to run faster than the resolution time you are using. And then we need to fully map the columns, right? So for that, we have 3 main data types that we can use. Label is just like the bug where neither gauge nor counter fit, right? So typically, for instance, if you have, I don't know, an IP address, you have a host name, text, those all will be labeled. And then the description can be anything you want. So this is just for your own purposes, right? Prometheus or Victormetrics will not use this. So then we have the gauge and counters, right? So depending on how the metric is behaving is if we should choose gauge or counter.
So I'm sorry, what was the difference between the gauges and the counters?
The difference?
The counters kind of obvious. What's the
Yeah, right. The counter counts. The gauge can go up and down.
Okay.
So
So for
counter basically is like monotonically increasing. In sense.
The label is just
Label is just string or yeah, whatever.
just curious, what type of the file is that? A YAML file?
Yeah, text file, but it's like this is if you use file would be just a text file,
So
right?
it's a
But
text file. It's not a
yes, but the syntax needs to be YAML. So these spaces need to be always the same. And you know YAML? Are you familiar with it?
Yes.
Okay.
Yeah.
Yeah.
So that's why I have question. If you write it down in the YAML file, so
Yeah.
do you need to install any type of modules?
No. PMM understands this. So
Okay.
you just this is your text file. You open it with Vim. You paste this, and that's it.
That's it.
Yeah.
Okay.
Yeah.
Isn't a YAML file required to start with 2 items?
I don't think so, but
It's definitely not.
yeah.
It's a best practice, but it's not required.
So
Oh,
it's-
maybe that, yeah.
So, for example, for the second line, if I want to do that in the Postgres, instead that it will replace with the Postgres, for example, pgstat statements.
Yeah. Actually, this may be not the best example here. This can be anything you want, but
Anything one.
yeah, this is just a string. I mean, it could be really it.
So can it be a kind of custom table name in your database? Anything.
Huh?
I mean, can it be a custom table? For example, you create a table T, whatever, that is not the default table in the engine.
Yeah.
Yeah.
So you can do that.
Yeah.
Whatever you
That's what
want.
he does here, right? He selects from schema.table.
Yes. Yeah. So, yes, this is not the database where you are going to be connected or the schema. This is just a name.
Okay.
Just a name that will be prepended to this. So I think I have an example here. Wait. This is not the best example, actually. But yeah, the metric in here, the column was replica lag, byte lag, and the namespace was PG. Right? So in here it said PG, and in here it said replica lag. Don't I have the example here? Yes. Okay. And this is not much. PG replication. No, this is not the same example. But yeah.
Prepended with an underscore, is that what it is?
You can. Yes. Yeah. You see here byte lag, PG replication, and yeah, I used another one. Sorry, because this is
the first
mixing.
two will be the namespace, and then underscore that will be the column name.
Yes,
Okay,
exactly.
I got it.
Yes,
Yeah,
exactly.
got it.
Yes.
So service name there is the column name, effectively?
Service name? No, this is the what I was saying before, that PMM actually helps us. It's intelligent enough to add labels, and these labels are the ones that we are going to then use to already get what PMM gives us. That is like, okay, you may have 100 servers here, and you will only want one, and then you filter by it.
Got it. Because those labels actually is at the beginning when you created the PMM client on the client server, you give them the label, and then PMM will be intelligent enough to pick
Yes.
up that.
Right.
later.
Right. Yeah. And then we will see, I will show you an example now, but there are many labels that are added by PMM client itself. So yeah, this is the example in particular with Postgres. We used this because we didn't yet have replication information for Postgres. So this is a query that we often used, and yeah, why not, right? And then the graph that, and you need to know PromQL, but it like the stuff that you need to know to have something working. You know, you don't need to be proficient on PromQL just to have like a basic graph done, right? What I generally do is I do clone the dashboard, so it's easier, and you have all the integration with the templated variables that PMM uses, and etc. And then yeah, you just basically copy. You can copy this and change the metric name, and yeah. Or if you see a nice graph in PMM, like we're going to see afterwards, there are like bar charts mixed with lines, etc. You can just get that and reverse engineer it, right? Instead of having to learn all of that.
What I like a lot is that you can select multiple metrics in a single query.
Right.
Many tools will
Right.
Zillion queries to get all the metrics.
Right. Yeah.
This is very
Yeah, and I have an example for that in my PMM. So the text file collector is very different. So it's of course kind of the same, but it's very different in its conception, because as we know here, for instance, the query collector will know to which database this is applying. So this is because the exporter itself is running this query, right? But for the text file collector, the OS exporter is going to run it. So it doesn't have, I mean, you could have one database or 50 in that server. So the OS doesn't know beforehand to which database that may apply. So text file collector can be used for data for database metrics, but we will have to have an additional layer of minor work, right? If you are going to use it for OS collection, then that will be perfect. For instance, processes running or processes not running, so you can alert, etc. We use text file collector for actually checking some patroni processes and make sure that we had the metric, so we could then use it with the integrated alerting, and that worked fairly well. It was nice.
So if I wanted to do something like, for example, to check the timing and quality of a connection to the database and the ability to do things on the database, have it all run, you know, under a certain threshold. So connect to brand new connection to the database.
Yeah.
Create a database within it, a schema, create a table, insert some data, you know, and this is all in a transaction.
Yeah.
Started a transaction, close the transaction, read the data back, verify it, and then I want the timing of all that. Would you expect that to be like a text file collector?
Yes. Yeah. And it's perfect use case for that. And let me show you an example, and you will understand exactly that is the best way of doing it. So to run it, like we had with the query collector, we didn't know, we didn't have to worry. In this case, to run it, we do have to worry, and it's on us. So this is what we were discussing before. The text file will be there. PMM will not know if it was written or if it like 1 minute ago or 1 hour ago, right? So it will read with the cadence that we tell it based on the resolution in which we add the file, and then it will just do it automatically without knowing anything else, right? So here again we have the online documentation and the tree showing the directories in which we need to add all the files. Again, we do have some templates that we can use that in this case they will show us what is the expected format that the file should have, right? So there are basically four ways of using metrics here. The simplest one is just the metric and the value. Again, PMM will add labels. In this case, it will not add the database one, obviously, because it doesn't know, but it will add all of them, like agent ID, the node name, etc. The second one is that we can use a specific timestamp if we want to hard code it, let's say. Then we have the ability to add one label to the metric, and this is what the example that we're going to use. And then we can add n amount of labels, all the amount we want, and the timestamp also, okay?
Sorry.
Yeah?
For that third example where you added the label, where's the label popping up down on the, so you have the comment, right? But like metric name 3.
Yeah, so this is just the syntax, say. And this would be a generic example. And you are going, I have one for this exactly, so let me show you.
Label underscore 1 was your label, right?
Yeah, in this case, it was like we can do service name because we are tricking PMM. Because this is a text file collector and it doesn't know the database which is being collected. But you know, I do know what service name I use to add my Postgres instance. So I can do this manually, and this will be hard coding the service name that we can then use in the dropdown to have this is an example that we were using. Like, I'm not sure if you're familiar with the MySQL InnoDB, the log usage dashboard, which is awesome. It can tell you information on redo log usage and how you need to size it. We didn't have that for Postgres, so we worked on it, and we came up with something like this. So and for this, maybe let me show you what I have in the testing. Can you see it there? So what we had before was the checkpoint stats here, right? So we only get information on when the checkpoints are going on. We don't have anything else, right? So if, let's say you have a checkpoint timeout on 10 minutes and you're seeing checkpoints every, I don't know, 3 minutes, 5 minutes, minutes. Okay, so how can you know the size of the max? It's impossible to know, right? It's just a guessing game. You start seeing checkpoints at checkpoint timeout. So we copied what we did on MySQL, that idea, and we came up with something like this, which may not be perfect, but I think it's working fairly okay. So what are we seeing here? Before, we used to have, let me go a bit to the left. So before, we used to have checkpointing all of the time. So this means like checkpoint is happening like crazy. So your wall files are definitely not appropriate for that workload. We are not sure for how much, right? So what we did, we added the checkpoint timeout here. On the right axis, we know that the checkpoint timeout is, so we would expect to see checkpointing every 5 minutes. So this already gives us a lot of information. This gives us information on the wall size not being enough. And here we can quantify it. Here we can say, okay, yeah, the max wall size was 128 megabytes, but every checkpoint timeout seconds, so this is aggregating writes that happen to the wall logs every checkpoint timeout. And it's dynamic because it uses the variables that we are getting from the server itself. So if we change checkpoint timeout, it will not be backwards compatible, but if we check if this is consistent for the period, then what we can know is, okay, then our max wall size is 128 megabytes, and we are writing every checkpoint timeout like 10 gigs. Okay, so let's increase it. Let's say, to 10 gigs. But in this case, I think we stop the workload, and it's not a constant one. But we can see how the checkpoints started to be more spaced out, and it wasn't still the best. It wasn't still the best size, because we still see checkpoints between fewer time than the checkpoint timeout, but we could get at least an approximation on, okay, in this case, I would have set it to 10, let's say, just to be, but you can quantify differently than just unknown, right? So yeah, this is what we did with the Textfile Collector here. What are we doing? So we are using the Textfile Collector because we need to have memory, because Postgres only provides us with the wall LSN diff function. So it's not like we can get the LSN and then tell it, okay, the last 1 second and something like that. So we of getting the initial LSN and storing it for our purposes. We are going to do an infinite loop. We are going to sleep every 10 seconds because we can do that because we are using medium resolution. And then we're going to say, okay, this is the new LSN, and this is going to be the difference from our first take that was this, and our current one. So now we can know how many bytes were written in this period of time. Okay, and then we will, of course, we will swap the difference here in the text file output, right? So we do this is just the echo for debugging purposes. Let's say it's not necessary for the script, but the necessary part is here. This is where we are going to write the information to the Prometheus file that we are going to then read, right? So these comments are totally unnecessary, and if you check with this, we are going to use this kind of syntax. So metric, label, and then value. Okay, so we have the metric. It's going to be named PostgreSQL wall LSN bytes. In this case, we don't have namespace, so whatever we use here is what we are going to see as metric name, the full metric name. Then we have the optional labels, which we, in this case, since it's database related, we want it to be linked to the server where we are connecting to. And then this is going to be the difference in bytes for the last period, right?
So the question about the service name, is that related with the label in your PMM?
Yes, exactly. And this is why then we can have something like this, that I can select, and this will get it, like, in this case, it will get nothing because it's not running there. But you can select the instance, and then it will work like any other metrics that we have, right? So you know that it will be applying to that server or to that database.
So I have a scenario that I label a Postgres cluster. So if I have 3 nodes, and then when I automate the process to install the PMM client on those 3 nodes, and they always get the same label, same service name.
Mm-hmm.
So will that be a problem here? Well, for example, the service name equals to cluster A.
Yeah.
And then actually it's going to gather matrix from 3 nodes at the same time. So my question is that, because in how you name the label on your nodes probably will be, if it's a very unclear or ambiguous on several nodes, and in this scenario probably will create a confusion when collect the matrix.
The label name here is something that PMM is using. Just hard coding the service name that otherwise built by the PMM client itself.
Okay.
So label-wise, you can use whatever you want if you know how to use it then in Grafana.
I guess if you want to deploy it, you want to template this where you put the label name while you template the file.
Right. Yeah.
On line 9, you're trying to get the difference for the current interval, right? So you're getting a difference between the increment and LSN initial.
Yes.
Doesn't LSN initial need to be updated each time the loop runs?
This is a good question.
Because it seems like it's taking a difference from when it first started running.
Yes, but as long as you always use the same measurement, you don't care.
Sorry, it's a string. It's a string. Never mind. It's gonna do code replacement. Sorry.
Yeah. Mm. And yeah, this is the one of the iterations of the files, right? So you will have the comments, which again are not necessary, and this is the metric, the label, and this is the value, right, in bytes. So then you would use that. I'm not sure if, and this is what we were saying about having different metrics in one, and let me show you the code. So what we're having here is, for instance, we have the PostgreSQL wall bytes metrics, but we also have the max wall size, so we can then plot this red line, so we get the max wall size, right? And then the green line is just, and let me show you the green line is just the same as the wall bytes, but instead of being aggregated every checkpoint timeout, this is going to be the rate. So we have more information in that interval, right? Because this big block of text tells us that there were like 10 gigs written in 5 minutes, but we don't know if all of them were written in the first second or if they were spread across. And this can also give us other leads on the workload that we have. And we are about to run out of time, and let me quickly discuss the external exporters. So the external exporters are actually a way of they are a way of easily getting metrics for things that are already being developed, right? So you can choose, let me see if we have a good internet connection, maybe. Yeah, so you can see here, there is a tremendous amount of exporters already done that are compatible with Prometheus, right? Which is all that we need for PMM, right? So if these are going to be exporting metrics as we have here in the text file exporter, so all of these will use this kind of syntax. If any of these will work, right? So I was saying before, we have, for instance, if you had Cassandra, and in last Percona Live, I think I gave an example of it. You can just install the Cassandra exporter, make sure that it's correctly publishing the metrics in the port. It says it's publishing them, and then you would just use PMM admin add with the external subcommand, right? So PMM admin add external, and then you do the host and the port. If it there are two kinds of external exporters. The serverless is the one that we would use for remote instances, and PMM client, and the PMM client is consuming metrics from an exporter that is running in another node or in the cloud maybe, and then the external will be local to the PMM client, right? So this is not the best architecture diagram ever, but it kind of explains this, or tries to. I'm not sure if it helps or not, but yeah, one is local and the other is remote, basically, right? And then, yeah, the PMM will also add labels and all of the metadata needed, and we will have our metrics in PMM. Okay, let me briefly mention how to troubleshoot this. We have the journalctl log outputs from the PMM client in all the client nodes, and this is very handy to troubleshoot and debug the advanced data exploration dashboard. And I think in this case I have a picture here, but since I have the running instance,
Your slides will be shared, right?
yes. If not, I can send them to you in PDF just right now. After the when we finish, I will send it to you. So let me go to advanced. And we have here all the metrics available at this time, right? So we can type, what was the name I was using for this? Wall size, wall bytes, right? So you have it here, you can click, and then you would have it here as if it were a gauge and if it were a counter, right? Already automatically being plotted for you, right? And you can, of course, do this like last 12 hours, last 24 hours, and whatever. And then we can say, we can troubleshoot. And something interesting here to show that I mentioned before is the amount of come on. The amount of labels and metadata that the PMM client will add for us, which is not showing completely.
You have to hover over the graph to get it, or?
But the graph, it will still be trimmed. I wanted to show, if you do this, in theory, no. Well, something had to happen, right? It couldn't be perfect. Wait, let me see if, because we also have the Explore dashboard, and we can use, yeah, and what was the name? PG. Yeah. We're going to run, yeah. And in here we have all the labels that are being added by PMM client, right? So service name, node type, node name, node ID, etc., etc., etc. So this is all done automatically for us by PMM client. And I forgot to mention the Explorer dashboard, but now you know you can also use this for running your custom prompt QL queries and troubleshoot and test and whatnot. And that is it. The last mention I would like to do is about creating dashboards and graphs. What I typically do is just clone the dashboards that we have because of the integration we have with variables and stuff. And we also get like the skeleton already formed with the graphs and the subsections, and then we just need to tune that, and it's way easier than just creating everything from scratch. And I'm not sure even if you create everything from scratch, if it would be the best because of all the templated variables and stuff. But yeah, do note that when you upgrade PMM, I'm not sure the current versions, but for sure the previous will step over all of this. So do your backups, do know where they are, and back them up. You can back them up in JSON, or you can check internally. These are stored in SQLite, so you can also try to query that and get only your custom dashboards and back them up. But yeah, if you upgrade, and this takes a lot of time, right? Creating dashboards, even for the simple example that I'm showing of the wall bytes, it really took me a lot of time. So yeah, it's not good to miss that work.
If you were going to try and figure out something complicated like SLO alert, monitoring, whatever. So like for example, let's say your database, you want the service to be down for no more than 5 minutes a month. Let's say that's your SLO, your service level objective. You know what an SLO is.
Mm-hmm.
So you don't care, of course, if it's down once for 3 minutes or whatever. You care if it's down 2, 3, 4, whatever times for a total of 5 minutes or more
Mm-hmm.
per month, sliding 30-day window. I need to know, I'm trying to figure out how to do that and burn rate. So let's say your SLO is 5 minutes a month. If in the first week you've already burned 3 or 4 minutes, you're going to exceed the burn rate.
Mm-hmm.
You won't get to the end of the month,
Mm-hmm.
so you should alert on that as well.
Yeah.
I'm having trouble writing those queries. Any idea what?
That's a counter, right? And you can do a text file collector just with that, like what I did here with the.
So the burn rate's not a counter though, but you're saying the SLO side.
The time that has been down since start of year is because it's increasing. It only increases, or stays the same. Like.
Although it has to be reset every 30 days.
Oh well, what you can do, yeah. Or you can restart the text file collector, your script. Like, if I restart, this will have another starting point. Let's say if you can your script, which will start on 0, and you do it in cron. I don't know, and then you loop over it, and the only thing you do is, okay, is it down? Okay, if it's down, you need to start incrementing that counter, and only then this will go up, and all the other time it can stay as a constant.
So
Mm-hmm.
I'm not positive, but for example, let's say it does trigger within, I don't know, 2 weeks in. I don't know if I need to reset it then, probably,
Mm-hmm.
my 30 days.
Right.
And I think there's a cleaner way of doing it than
Yeah.
It doesn't matter, you can just keep counting your time that your downtime as a counter. You just look at the last 30 days or since the first day of the month, and you then
But
take that
that's-
as a beginning point, and you
But
know
I-
how many seconds or minutes you've been down.
But I don't know if it's necessarily the first of the month per se, or so much as first of the month or the last time.
That's just a matter of writing the correct query, I think.
And that's what I'm saying. I'm pretty sure it can be done at the query level as opposed to, cron.
Mm-hmm. Yeah.
logic.
Yeah.
But I'm trying to figure out the best way to learn that more advanced syntax.
But using the file collector, you can accommodate for the times when your service is down, like MySQL or Postgres is down. But when the server goes down,
You don't know because it's down. Yeah, this is my point. I'm not sure.
So what he would like to do is, based on whatever Prometheus or parametrics hold, if you go below a certain threshold, like if you're getting MySQL up, for example, to be 0, you want to count the number of times that it reports 0.
Mm-hmm.
Even if the server is down or the service is down, it doesn't matter because it will get the 0 value.
Mm-hmm.
And then you need to count how much time it has been 0. And that's a hard one.
Right. Yeah. That I don't know. Yeah. It's a very good question, though. Yeah.
That's why it's
Yeah.
Spent a fair bit of time on it already.
You figure
Yeah.
it out, you can get the next talk.
Yeah. Will be a nice blog
I
post.
actually will, once I get it all worked out, I will talk about it. Awesome.
Nice. Yeah, I think that was actually it. We are hiring, and everything we do is open source, as you already know. So I'm not sure if you have any questions. Otherwise,